Here this question is asking a modulating signal m of t is given by a part m of t is equal to cos 100 phi t plus 2 cos 300 phi t, and the b part is asking m of t is equal to sin 100 phi t sin 500 phi t. So here we have two signal provided, and in each case we have to do all these 5 questions. Here for this video I'm just gonna deal with the a part here because it's gonna take a lot of space, so I'm gonna deal with the b part in my next video. So here I'm just dealing with this one. Okay, only this one I will do it in the next video. And let's look at the questions asking. So first question is asking sketch the spectrum of m of t. So here if you look at this is cos 100 phi t, and then 2 cos 300 phi t. From this one you can right away find out where is the center of this one located by finding out the frequency here. So I grab we are dealing with the a part and a first one. Okay, so I rewrite the equation, that is m of t is equal to cos 100 phi t plus 2 cos 300 phi t, and here we want to write this one in terms of 2 phi ft, so you can clearly see what is the frequency here. So I write 2 times this one 50, or I can put like 2 phi ft for myself, 2 phi times 50 t. Okay, that is this, and then plus here we have 2 cos, and this one also I can separate like 2 phi ft form. So 2 phi f is going to be 150 and then multiply by t, or you can just put t or multiply by t because we want to just clearly see the f. So here you have to just know for the first one it's 50, the frequency is 50, and for second one the frequency is 150. So if you draw the diagram it's going to be, this is going to be at 50 and this is going to be at 150, but it's going to be positive and negative as well. So if you draw the we can also mention it right here, fm1 is equal to 50 hertz, fm2 is equal to 150 hertz. Based on that we can draw the diagram. So here we are gonna have 50 hertz, that is over here, and the height of this one is going to be half of the amplitude, that is in this case this is 1 amplitude, so this is going to be half here. The next one is 150, the height of this one is going to be 1. Okay, so from this one we can see this side is 1, this is going to be half, and this one is minus 50, and this one is 150, and this one is minus 150, and this is M of F, and this one is F. Okay, that's all you had to know, and that is part 1. Now let's look at the part 2. Part 2 is asking, find and sketch the spectrum of the DSB-SC signal 2m of t cos 1000 phi t. So here what you are doing is, let's say this signal is sent through this, then what's going to happen? So this is also mentioned, this is double side band. So what's going to happen is, when we send through this, the center of this one is going to be located at the frequency of this. So this is frequency. Right away you can see that this is cos 1000 phi t, so 2 phi ft. F is going to be 500. So this signal is going to be shifted 500 to the left and also 500 to the right as well. Okay, so we are gonna have double-sided band, and it's going to be shifted negative 500 and positive 500. The middle part will be located at that, and you have to put the other values according to that. Like, you can also copy paste this one, and if I copy paste, that will be much clearer. Like, let's see, I go to a new page. So for this one, you don't need a lot of calculation. From the equation you can right away draw the diagram, but we are going to derive the equation as well, so I will do that after I draw the diagram. So for this one, I go here, I copy this, okay, and then I paste it over here, and then I move. The center of this one should be 500. So if this one 500, then you can think about this is going to be 450 and 450, and this one is 100 from that, so 350. So the first point is going to be starting at 350 here. Okay, and the same thing goes to the other side as well. Okay, this one's also going to start at 350. Okay, so this one should be same height. This is located at 1, and this one doesn't exist. This is the middle part of it. Okay, and these two are 1. And these two are half. And the center of this one is located at 500. This one is negative 500, and this one is 500, positive 500. And now you have to change all the values accordingly. If you shift, you have to think like negative 500 to right side 50, how much is going to be? This is going to be 450. If this one is 450, then this is going to be negative 350, and 50 to the other side, that's 550. And this one is 650. Okay, here also same value, but all of them are going to be positive. That's the difference. So this is going to be 350, then this is 450, this one is 550, and this one is 650. Okay, and this is MFF, and this one is frequency. Okay, so this is going to be the diagram. Now if you want to find the expression, then we have to just plug in the given equation. Here you see this is given by 2m of t cos 1000 t, phi is given by 2m of t cos 1000 phi t. Okay, then here what we do is we just plug the m of t value, that is this one. We are just dealing with the first one, so plug that one here. So 2 cos 1000 phi t, and I plug the m of t value, that is cos 100 phi t plus 2 cos 300 phi t. Okay, and then we can multiply this 2 cos 1000 phi t by this one and this one. If we do that for the first one, we will get two cos 1000 phi t cos 100 phi t plus 2 cos, okay, this one should be 4 cos, because if I multiply this one by this, that's 4 cos 1000 phi t, and then cos 300 phi t. Okay, so this is what we have. Okay, then after that this one becomes when we have two cos multiplying, there's a cos property. Once you apply that, you will end up with this one, cos 1100 phi t plus cos 900 phi t. Once you apply through the property, you see this value become half, and then it's going to be addition, and then each time whatever the value we have here is increased by that one time and decreased by that one time. It's like a plus b. If we have cos 2 of the multiply, is the equivalent is half cos a plus cos a plus b plus cos a minus b. The bigger one takes the a's place, though in this case the bigger one is 1000, so that's going to take the a's place, and b is going to be the smallest value, that's 100 in this case. Okay, same thing apply for this one as well. So this value become half, and we will get addition of these two, and the upper part, the bigger one is going to be a, lower one is going to be b, and addition one time, subtraction one time. So if you do that, this is going to be cos 1000 plus 300, that's 1300 phi t, and then plus then 2 cos 1000 minus 300, that's 700 phi t. Okay, so this is what we have derived, and we can go ahead and write one more step to find out the frequencies each of, like finding out frequency, you can draw these locations. Okay, I right away from this equation is clear, because we found out the frequency and we shifted this previous graph to 500 left and 500 right. You can do that, or you can derive the final expression and find all the frequency, and you can plot the values. That's gonna be exactly the same as this. So here you can if you write this one in terms of 2π form, then this is going to be cos 2π, and then this is going to be 550. Okay, and then t. Okay, like that you can see all of them. So 550 we have one, and then like that this one is going to be 450 cos 2π times 450 t, and this is going to be 2 cos times, this is going to be 650 2π times 650 t, and this is going to be 2 cos 2π times 350 t. Okay, so all of the frequencies are like visible right now. So from that also you can draw this diagram. And let's look at the next part. The next part of the question is asking, from the spectrum obtained part 2, suppress the lowest side band spectrum to obtain the upper side band of the spectrum. Okay, so here we have to just suppress the lower side band. Okay, so in order to do that, we have to know what is a carrier signal and what is not. Okay, to find out the carrier signal, you have to use this equation to make it clear. So I put it as 3. Is it 2 or 3? Yeah, 3. We are doing the third part. So this expression for the DSB-SC signal that is given by here, that's provided right here, that is 2m of t cos 1000 phi t. Okay, so from this one we can find out the carrier signal, because this one contains of m of t and c of t. C of t is the carrier signal. So from this one we can say the carrier signal is, if I remove this m of t, then the remaining part is 2 cos 1000 phi t. That's a carrier signal. Okay, and the frequency for this one is, you can find it by putting 2π forms. So this is going to be 2π times 500 50. Okay, so from that we know that upper side signal is whatever the value that's above this, and lower side band is going to be whatever the value that is below this frequency. So we can mention it here, true. The USB spectrum the frequency component above the carrier frequency 500 hertz are allowed. So here we are interested in the upper side band only. So we have to look at from this one what is above 500. So in negative, that's the lowest, that's negative 550 and 650. In the positive, that is positive 550 and 650. So those are the only thing we are going to have for the upper side band, and we omit these inside values, inside graph. So if we just draw the outside one, that's going to be the upper side band. Okay, so here we can draw the spectrum for USB spectrum. So here we have 550, this negative 550, positive 550. Okay, and also we have 650, negative 650, and a positive 650. And the height for this is going to be 1. This is negative 550, 550. This is the height of this one is half. Okay. Okay, so that's gonna be it for this one. And let's look at the fourth part of the question. The fourth part is asking, knowing USB spectrum in part 2, write the expression ϕUSB of t for the USB signal. Okay. So we have to just write the expression. So the expression is going to be basically the one we derived here without the lower side band. So here if you look at this, the upper side band is 550, that is this, and also 550 and 650. Okay, these are the two upper side band, and that is belong to cos 1100 and 1000. So that's gonna be the equation we are gonna put here. Write the expression for the USB signal from the spectrum ϕUSB of t is equal to cos, and then 2πft, that is 2π times 550 times t, and then plus 2 cos 2 times 2π times 650 t, and therefore phi of USB t is going to be cos 1100 phi t, and then plus 2 cos 1300 phi t. We just wrote these two values, and this is the equation we derived. Okay, and that is for the part 4. Now let's look at the part 5. Part 5, repeat the parts 3 and 4 to obtain LSB signal in both time and frequency domain. Okay, so it's basically exact same thing. For the part 3, wait a minute, let me double check what is there. So for the part 3, for the part 2 we draw this DSB, and part 3 we draw the USB spectrum, and we wrote the expression in the part 4, and repeat the parts 3 and 4 for the lower side band. Okay, so for the lower side band also we had to just draw the diagram, and then I'm kind of confused here. This one should be 2 here. This one should be 2. Is it 2 or 3? Yeah, 3 is the one we write all this thing. Part 1 is sketch the spectrum, find the DSB-SC, that is this. That's part 2. Yeah, we can write it here. Part 2 here. Part 3 is this. Part 4 is this. Now we have to do the same thing for the lower sided band. Okay, now we know the carrier frequency, and carrier frequency, the above part of the carrier frequency is the upper side band. The below part of the carrier frequency is the lower side band. So here, if you look at the graph here, 500 is the carrier frequency. So whatever the value above 550, 650, that's upper side band, and the lower side band is going to be this one, 450 and 350, 350 and 450 right here. So that's going to be it for that, and the expression is basically the other two, like look at these two. These two are lower side band. Okay, now let's go ahead and write that. So we are doing part 5 here. To draw the lower side band spectrum, the frequency component below. The carrier 500 Hz allowed. So this is 350 and 450. This one at the height of half, and this one's at the height of 1, and this is LSB, and this one is frequency, and the right the expression for the LSB signal from the spectrum. ϕLSB of t is equal to cos 2 phi f is 450 t plus 2 cos 2 times 2 phi times 350 t now ϕLSB of t is equal to cos 900 phi t plus 2 cos 700 phi t, and you can see that here as well. Okay, cos 900 phi t, 2 cos 700 phi t, and stuff. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.